Okay, topic 9 is all about applications of linear functions. Remember, when we see applications, that means word problems. There are many ways to approach word problems. This first concept that I'm going to go over, called the cubes method, is just a method what is it called? Like an acronym to help you remember the steps of solving a word problem. I don't expect you to use this method. This method is just something I'm showing you. This is the way we teach in high school how you solve a word problem. So I'm just giving you this information in case you find this useful. So the cubes method, that just tells us all the steps to go through a word problem. So C stands for circle the important numbers. U, underline the question. B, box the keywords. E, write the equation. And S, solve and write a sentence. So the important things here, I don't need to see you underline, circle, box. If that helps you, do it, but I'm not grading you for doing that. What I am looking for is that you write the equation, you solve it, and you write a sentence explaining your answer. Okay. So before we look at some word problems, we can write some examples of keywords for each operation. So another way that we could see the word addition in a word problem would be what? Good. It could just simply say add. Anyone else? More. Okay, yeah, more than. Include. The sum. Combine. Yep, any of those words means that we're adding those together. What about subtraction? Good, we could see less than. What else could we see for subtraction? Minus. If our word problem is talking about water and it says the water is leaking, that would be subtraction. Leftover. Good, and these are just words to help you get familiar with these operations. What about multiplication? What words could they use besides saying multiply? Times. One good word you'll see a lot is per. So for example, $8 per pizza. That means $8 times how many pizzas you get. Okay, any other words for multiplication that you can think of? Good, each. There's tons of words here, so we're just listing a few. And I thought of another one for addition, plus. As you guys said, minus here. Okay, what about division? Divided by. Any other ideas for words? Yeah, I guess it's on how it's wording it. So yeah, if it's asking like, how many does each person have, and you have to use that division. So yeah, we could use each again.
What about distributive?
Distributive, yeah.
A certain amount to a certain amount.
Good. Say that again. Good. So yeah, if you're given a total in a problem and it's telling you to separate that total, yeah, that would be division. So let's say separate a total. Okay, and these are all some good words. And there's, like I said, there's tons and tons of words for each of these. This is just to get us familiar with some words that could pop up. So let's go ahead and look at example 1. So example 1 says container A and container B have leaks. Container A has 800 milliliters of water and is leaking 6 milliliters per minute. So before I even continue on in that problem, I am going to write that equation. Okay? So this is all about container A in this first part. Okay? So I'm going to write A is equal to, because A is going to stand for our container A, and it says container A has. So it says 800 milliliters of water. Okay, so 800, and is leaking 6 milliliters per minute. So is leaking would be what operation? Minus. And then 6 milliliters per minute tells us we're going to have a multiplication in there. Good. It would be 6x because we don't know how many minutes, right? So we're saying that minutes is x and container A is A. Okay. Now continue on to our problem. It says container B has 1,000 milliliters and is leaking 10 milliliters per minute. So now we're going to do that equation. So we have container B has 1,000 milliliters, is leaking, is what operation? Minus, and what would be 10 milliliters per minute? 10x, because we said that minute is x, and container B is just going to be B. Okay. Then it says how many minutes M, I guess minutes was supposed to be M, but we're going to say x, will it take for 2 containers to have the same amount of water? So what are we going to do to these 2 equations to find out when they'll have the same amount of water? Say it a little louder. Equal to each other, yes. So in order to determine how many minutes it will take for both to have the same amount, this is your keyword here, same amount, means we're setting A equal to B. Okay, so that means that we are setting A equal to B. Well, we know that A is 800 minus 6x, and B is 1,000 minus 10x. Okay, now we have an equation with only one variable, and that's what we're looking for because we haven't talked about 2 variables yet, system of equations. We're just doing linear. Okay, so we're solving for x here, so that means we have to get the x's to one side and then the numbers to the other. So I'm going to go ahead and move my x's to the left and my numbers to the right. And remember, it doesn't matter if you choose to do the opposite. Okay? So I'm going to add 10x, and I get 800 plus 4x equals 1,000. And then I'm going to subtract my number, 800, over to the right side, and I get 4x is equal to 200. Okay. Then if I divide by 4, 200 divided by 4 is what number? 50. So I get x is equal to 50. And what did x stand for?
Minutes.
Minutes. Okay, so here I have my equations written down. I have my work written down. But since I am dealing with an application, my answer has to be in the form of a sentence. So it was asking us how many minutes will it take for the 2 containers to be the same amount of water? So what would be my sentence? Correct, and I would just accept it will take 50 minutes. That first sentence is better because you're putting more information in it. But as long as your sentence makes sense to answer the question, I'm not looking for all that extra detail because it's a math course. Don't need to be writing paragraphs here.
I was about to turn in MLA format,
No,
response.
no, please no. I don't even remember what that is. Okay. Number 2, Tim is choosing between 2 cell phone plans that offer the same amount of free minutes. AT&T's plan charges $39.99 per month with additional minutes costing 45 cents. So that's going to be the first part that we are going to turn into an equation. Okay? So let's go ahead and say Let me actually look through the problem, make sure it doesn't give us a variable this time. Okay, it does. So it's saying minutes is A, but it doesn't give us anything else. So let's say AT&T, let's list as a capital T to not confuse with our lowercase a, and then Verizon, a V. So looking at the part that I just highlighted, it says AT&T plan charges. So T equals $39.99 per month. Is this problem asking about the months or is it asking about the minutes? The minutes. So that means that $39.99 is just going to be as is. It's not going to have a variable attached to it. So with additional would be what operation? Addition. And then it says 45 cents per minute. So 0.45, and then what's our variable for minutes? A. So that's our first equation. Then it says Verizon's plan costs $44.99 with additional minutes at 40 cents. What would that equation look like? Perfect. V is equal to $44.99 plus 0.40A. Okay. This one is saying how many additional minutes A will it take for the two plans to cost the same? The same is the key word here. So what do you think we're doing to these two equations? Setting them equal to each other. So $39.99 plus 0.45A is equal to $44.99 plus 0.40A. Okay, so same thing we did above. We're going to get our variables to one side and then our numbers to the other. Okay, and I always just keep my variables to the left and then my numbers to the right. But again, anything opposite that's going to work, that's fine. Okay, so I'm going to first move my A's over. So I'm going to subtract that 0.40A. And I get $39.99 plus 0.05A, so 5 cents a minute, is equal to $44.99. Then I'm going to subtract that $39.99 over. And I'm going to get 0.05A is equal to, what is it, 5? Okay. And then I divide both sides by that 0.05. And I get A is equal to 100. What would our sentence be? Good, it would take 100 additional minutes, okay? So it will take 100 minutes, that's fine. What I'm looking for here is that you understand what you found. So it will take 100 minutes. So I see my equations, I see my work, I see my answer, I see my sentence. If that's all correct, that's full points.
Question.
Yes.
So on that 0.05, would 0.5 be acceptable, or would that change the equation?
0.5 means, if you're thinking of money, would be 50 cents. 0.055 cents. So think of it that way. Two different numbers. Okay, number 3 says a bicycle rental company charges a flat fee of $10 plus $2 per hour to rent a bike. Says write an equation in slope-intercept form for the cost of renting a bike for this company. Okay, so in this case, we're not writing two equations. It's just telling us to write one equation, and that equation is in that first sentence. So a bicycle rental company charges a flat fee of $10 plus $2 per hour to rent a bike. And since it's telling us to write it in slope-intercept form, that tells us right away what variables we're using. And what is that?
X and Y.
X and Y. So y is equal to mx plus b. Okay. So the company is going to be y. Okay. And what is x going to be? No?
Oh, no.
What is x going to represent?
Total per hour.
Per hour, right here. This is x. So that means my equation is y is equal to 2x, right? Because it says $2 per hour. Anytime it says flat fee, you know that's going to be the number after that y equals mx. It's that b part. So a flat fee of $10. So that's our equation. Y is equal to 2x plus 10. Here it's asking us a couple different questions. So it's saying, how much would you be charged if you rented a bike for 8 hours? So where would we plug in that 8? And for x. So we have y is equal to 2 times 8 plus 10, which gives us y is equal to 16 plus 10, which gives us 26. How would we write that as a sentence?
You would pay $26 for 8 hours.
Correct. You would pay $26 for 8 hours. Okay, but that's not the whole problem because we still have one more question here. How many hours did you rent a bike if your total cost was $42? Now, what is it telling us to plug in? X or Y? Y. So we have 42 is equal to 2x plus 10. And now we're finding the amount of hours, so our x value. So I would subtract 10, and I would get 32 is equal to 2x. Divide by 2, and I would get x is equal to what? 16. Okay. So what would be my sentence for this one? Good. $42 will get you 16 hours. Nothing fancy here, just the sentence has to be able to tell me or show me that you understand what this problem is asking. Okay. Number 4, we have another problem involving container A and container B. So it says container A has 20 liters of water and is being filled at a rate of 6 liters per minute. So now our container is not leaking, it's being filled. So what is filled? What operation? Plus. Okay. And then I'm going to go through my problem and see, okay, it's giving me the variable for minutes. So we're using m now instead of x. So m. So if I was to write my equation for container A, I would have A is equal to what? 200 plus 6m. Good, and we're just using m because they gave us that in there. They gave us the m. Okay, now let's look at the next equation for container B. So container B has 500 liters of water and is being drained at 6 liters per minute. So what would that equation be? 500 minus or 500 plus?
Minus.
Minus, because it's being drained. Someone said that. I was just, making sure everyone caught that. So in the first container, it's being filled. The second container is being drained. Okay. Then it says how many minutes m will it take for the two containers to have the same amount? Keyword is same amount, which tells us what? Set it equal to each other. So 200 plus 6m is equal to 500 minus 6m. I'm going to move my m's to the left and my numbers to the right. So I'm going to add the 6m over, and I get 200 plus 12m is equal to 500. Now I'm going to move my numbers over. So subtracting that 200, and I get 12m is equal to 300. Divide by 12, I get m is equal to 25. Okay, and what would my sentence look like?
It will take 25 minutes.
Good. It will take 25 minutes for our containers to have the same amount of water. Okay. Number 5, we have UPS charges $7 for the first pound and 20 cents for each additional pound. Okay, so that's our first equation. I'm going to look through the equation real quick and see if it gives us a variable for pounds. Does it?
Yes, P.
Good. So we're going to use P for pounds. So UPS charges. So we're going to say UPS is the variable U. Okay, so we have U is equal to
7 plus 0.20.
7 plus 0.20 what?
P.
P. Because 20 cents for each additional pound. Okay, next equation, we're talking about FedEx. So FedEx charges $5 for the first pound and 30 cents for each additional pound. What would that equation look like? Good, so I'm going to say FedEx is F. So let's say F is equal to 5 plus 0.30 P. And then what is it asking us to do in this problem?
Equal, because it says same.
Same, so set it equal to each other. So 7 plus 0.20 P is equal to 5 plus 0.30 P. I'm going to move my P's to the left and my numbers to the right. Okay, so subtracting that 0.30 P, I get 7 minus 0.10 P is equal to 5. Okay. Then I'm going to move my numbers over, so I'm going to subtract that 7. And I get negative 0.10 P is equal to negative 2. And if I was to divide both sides by that negative 0.10, I would get P is equal to what number? 20. What would be my sentence? Good, so 20 pounds would mean they would cost the same.
It'll cost the same as 25.
Yeah, it will cost the same at 20 pounds. Remember here, your answer is not complete until you have that sentence. Okay, number 6 says a 12-inch candle and an 18-inch candle are lit at 6 p.m. Okay. The 12-inch candle burns 0.5 inches every hour, and the 18-inch candle burns 2 inches every hour. At what time will the two candles be the same height? Let H represent the number of hours. Okay, so we have two equations here. We have one equation dealing with the 12-inch candle. So we're going to say that 12-inch candle, let's represent that as A. And then we have our 18-inch candle that will represent at B. In this problem, they're trying to trick you by adding those numbers in there, those extra numbers, the 12-inch and the 18-inch. That is just separating the two different type of candles. Okay? Separating the two different type of candles. So we have candle A is equal to 12, and then it says burns 0.5 inches every hour. So burns would be what? Minus 0.5. And do we have a variable for hour? H. Okay, the second candle, which I labeled as candle B, what's the starting height for that candle? And then it says burns, so minus 2 inches every hour. 2H. Okay. And it wants us to find the same heights. So what are we doing to the two equations? setting them equal. So 12 minus 0.5h is equal to 18 minus 2h. Okay, just setting up my problem. I'm going to move my h's over to the left. So when I add 2h, I get 12 plus 1.5h, right? Because I'm subtracting that 0.5 from 2, is equal to 18. Subtract 12 from both sides, and I get 1.5h is equal to 6. If I divide 6 by 1.5, I get h is equal to 4. Okay. My question says, at what time will they be the same? So it's asking for a specific time here, and that 4 only represented hours. Does it say somewhere in the problem what time it started?
6 p.m.
6 p.m. So if it started at 6 p.m. and we got the answer will be the same 4 hours later, what time is it? 10 p.m. So what's my sentence? Good. At 10 p.m., the candles will be the same height. Okay, so these would be one of the examples where your sentence is including a different numerical answer than the answer that you got. Because here only gave us hours, but it was asking for what time.
So in this case, like the 12-inch and 18-inch is kind of like in the phone line question where it gave us the base cost of the price.
Correct. Correct. Yes. Number 7 says, on Saturday, a local bowling alley charges $2 for shoe rentals and $3.50 per game. So that shows us our first equation. Then it says, on Sunday, the shoe rental is $5 and each game is $3.25. So that is our next equation. If you spend the same amount each day, how many games G were bowled? So we have the keyword same amount and then our variable G for games. So let's first start off by writing the equation that I highlighted in green. Okay, so I'm just going to say Saturday's A, Sunday's B. So I have A is equal to what? Good, so 2 plus 350 G. So $2 is your flat rate. You pay for your shoes. And then every game you bowl is $3.50. So that's why it's $3.50 G. What about the B equation? So B is equal to?
5 plus 3.25 G.
Correct. Okay. And it wants us to find out after how many games do we get the same amount. So what are we doing to the two equations? Setting equal to each other. Move my G's to the left, my numbers to the right. So I'm going to subtract 3.25 G over, and I get 2 plus 0.25 G is equal to 5. Subtract 2, and I get 0.25 G is equal to 3. If I do 3 divided by 0.25, I get G is equal to what? 12. So what does that tell us? What's our sentence? Good. 12 games were bowled. Okay, number 8 says you're looking for an apartment. Apartment A has a $1,000 security deposit and costs $1,200 each month. So that looks like our first equation. Apartment B has $1,500. That is missing security deposit. Has a $1,500 security deposit and costs $1,175 each month. Second equation. It says after m months, so it gives us our variable. Will it take for the cost to be the same? So we're setting them equal to each other. So what would be the equation for apartment A? Good, 1,000, that's our security deposit that you pay one time, plus 1,200 a month, and we say month is M. What about equation B? $1,500, because that's our security deposit, plus $1,175 M. Okay, it's looking for the same, so we set them equal to each other. Okay, I'm going to move my M's to the left, my numbers to the right. So I'm going to subtract 1175 M. And I get 1,000 plus 25 M is equal to 1,500. Subtracts 1,000. And I get 25 M is equal to 500. So if I divide by 25, I get M is equal to 20. So what would be my sentence? Yeah, it'll take 20 months before these apartments cost the same. So they will cost same at 20 months. Any questions so far on these applications? Number 9 says a caterer charges $120 to cater a party for 15 people and $200 for 25 people. Write an equation in slope-intercept form. And then it says, what does the slope represent and how much would a party cost for 40 people? Okay, so in this problem, they don't give us the equations. Instead, they give us 2 points. So we have the first point here, $120 for 15 people, and the second point here, $200 for 25 people. So we would write that as X comma Y. So 120 comma 15 and 200 comma 25. If it wants us to write it in slope-intercept form, we first need to find the slope, right? We need to find the slope before we could put it in slope-intercept form. So remember, the slope formula is M is equal to Y2 minus Y1 over X2 minus X1. And I would just label my points X1, Y1, X2, Y2. And then I'm going to plug in these numbers. So Y2 is 25 minus Y1, 15. X2, 200 minus X1, 120. So I get 10 over 80, which reduces to 1/8. This is our slope. Okay. It says, what does the slope represent? So what does this 1/8 represent in terms of this problem? Per person, it costs how much? $8. Okay, so each person is $8. Okay. Our question here is how much would the party cost for 40 people? So we have the equation y is equal to 8x. We don't have any additional information about the y-intercept. So y is equal to 8x. So where would we plug in that 40? X. So we have y is equal to 8 times 40, which gives us 320. And that 320, if we were to write that in a sentence, we would say what? Good. It will cost $320 for 40 people. Okay. So in this type of problem, we did not just have to write the equations and set them equal to. We had to notice in here that they were given us points, and we had to find the slope.